But now we're going to hear what our friend Uroš Škerjanec has to tell us from development technologies at Zarja Elektronika. We're going to hear Uroš technical protection of lead acid battery. Ooh, that one is good for batteries, especially on the production line. Welcome, Uroš. Your 15 minutes starts when you say you're ready.
Okay,
You ready?
I am.
Okay. Gremo.
Hello, everybody. My name is Uroš Škerjanec, and I am one of the guys in Zarja Elektronika who works in technical support team. That means that I get to help support my team with, let's say, a special fire detector, all kinds of special fire detector systems, and I'm involved in very special, let's say, projects that are one of a kind, probably in whole Slovenia. So basically, what I'm gonna present to you today is one of the special projects that we did in the past 2 years for our customer. They are manufacturer of lead acid batteries in Slovenia, and they want us to help them detect rise of temperature before something happens. See, because of the environment of that production line, it's very hard to detect everything. So even before we started with the design of our, let's say, final solution, we faced few challenges, which are hard environment. When you stepped in those production line, you could even taste the smell of acid. High voltage power station, who then are connected to the pellets of the batteries. Small area of detection, you can see the connection between two batteries is very small. And what I already said, the customer wanted to prevent explosions of happening. And of course, by the end, when we go through all those challenges, we found out that there are also some human errors which could not be avoided. And when we checked all those spots with lines, we decided to go with Adico's special fire detectors, hotspot basically. They are from German manufacturer GTE and are very good for harsh environment. They can detect temperature on a surface with a rate of temperature rise. How should I call? And our project was staged in 3 phases. These are the phase 1 and phase 2 of the floor plan of the factory, of the production line. You can see for the phase 1 we use 25 hotspot detectors, and for phase 2 we increased that number to 51 detectors. The challenges that we faced during the installation was very narrow access to the pallets, very narrow, very hard to get in for our technicians. And even when we did that, some pre-installed installations were already there blocking the view of the detector. So on that note, we had to do some customized mounting. We used Hilti profiles for that solution. And in phase 1, we mounted our detectors between 3 to 5 meters, or let's say basically between phase 1 and phase 2, we used those 3 and 5 meters of height for detection purposes. This is a picture of how the pallet of the batteries looks like at the customer site, and how it's connected to the electrical power station, which is now being, let's say, electrified for batteries to work. And those batteries are connected to one battery at a time. And in one pellet, you get, let's say, 44 connection points that needs to be connected. This plate here is approximately 15 square centimeters, basically 1.5 centimeters wide and 10 centimeters long. It depends from the pellets and the batteries size. This is the point of, let's say, the view, what detector sees, how can detect. And this is from, I think, 5 meters of height. And it's very small area for detection because the temperature, the height of temperature is coming from that connection metal plate between the two batteries. If they are not screwed in like they should be, then you have a problem. Some thresholds for, let's say, end configuration that we used is 63 degrees in phase 1 and 75 degrees in phase 2 for the end configuration. You can see here in this picture where are the hotspots mounted. I tried to visualize how they are, let's say, the point of view or the angle of the view, and the axis of those batteries is very narrow and very hard to detect everything, every plate. In the left picture, you can now see close up where all the heat, excess heat is coming from between two junctions. And this plate can heat up during the process to 140 degrees, and this is like, say, a normal temperature, and it's not unwanted. The problem becomes when on the right side you can see I circled it, where there is a excess room between the battery and that metal plate, where there is too much room. The extra heat comes and it could damage the battery, and you have an explosion. If you have an explosion in this kind of environment and the employee walks by, you get a catastrophic for, let's say, for employee who got injured. Even some small local fires could start. After that successful phase 1 and phase 2, they asked us to do the same in Macedonia with phase 3, the same company. We used same technology, Adicos detectors, just different production line or different size of batteries. In Macedonia, there are even the production line is different. They are producing those small batteries, 12 milliamp, 12 amps and 12 volts batteries, which are, let's say, used in most fire panels or security panels. So the production line is a bit different. So again, we had to customize our mounting. We again used Hilti profiles to mount our detectors to the final location. And again, it was a very hard detection. We could not detect it from above. We had to detect it from the side. Like in this picture, you see, you have to detect from different angles the whole production line. And this is a temperature, how the detectors see the battery, the temperatures. You could not, okay, it's a blurry picture, but you get the point. You have more than 900 pixels, each representing each temperature of that spot. And if, let's say, one spot rises a temperature, you get an unwanted heat. And if you have an unwanted heat, there you have an explosion. And an example of one of the unwanted heats occurred while we were there. I circled it. And of course, with all that data, We then we connected all our hotspot to a PC to get all the data for, let's say, history, so we can, through data, optimize our final configuration. And you can also have the graphic line of each of those 16 areas of detector. And basically, this is it. Thank you for having me.